Hey everybody, welcome back at Bavarian Demons YouTube channel and our setup videos. Today I would like to show you how to install an AXON unit on your helicopter. The first thing we have to decide is if we want to connect the AXON using the cable loom option. So get channel by channel from the receiver into the AXON unit, or if we want to use a serial connection setup using only one patch cable to connect from the serial output port of the receiver into port B of the AXON, which is the serial input port. In the following example, I will use the serial connection, as this is what I have prepared on my helicopter already. For how to connect the cable loom to the receiver, simply take a look at the manual. It's easily explained in there, step by step, channel by channel. Let's take a closer look at how the cabling and the whole installation looks on the helicopter. So we have our AXON unit mounted to the helicopter's gyro platform, and we do have all the cables wired up according to the manual's diagrams, which is in our case the serial input on port B, so this patch cable runs down to the receiver. We do have our 3 head servos, number 1, 2 and 3. We do have the tail servo on port 5, and as we are using a serial input to the unit, we have the throttle output right here on port 6. I just want to spend some words on the Swash plate servo setup. So what is servo 1, 2 and 3? Well, pretty easy. The servo on the left side, linking to the left side of the Swash plate, always is our servo number 1. Servo linking to the right side of the Swash plate is servo number 2. And the servo that's linked to the center, either in the front or the rear, the Swash plate can also be 180 degrees tilted. So in this case it's in the back. The center servo is number 3. And this is exactly the order the servos are connected to the ports 1, 2 and 3 of the AXON. In case of an H4, a 4-point linked Swash plate, simply take a look at the manual. The connection schemes and numbering of the servos is all explained in there. Once we are done with our cabling, we simply use a PC or a Mac, we do have both software packages available, to set up the system. So use the supplied USB cable, connect it to your computer and to the unit itself. The unit will be powered just by using the USB cable, so in the first step there is no external power source needed. The software will now give us the option between using the expert mode, which gives us the possibility to access every single parameter itself. For the initial setup, we do highly recommend to make use of the setup wizard, which guides you step by step through the first setup of the AXON unit. To start the setup wizard, we now simply click exactly that button. And this takes us right into the first screen. You can see it on the left top. The screens are numbered, so this is number 1. And right here we have the navigation buttons, which guide you through the setup wizard. Let me just point out that there will be a lot of notes and suggestions, hints, tricks on the left side on the screen, things you really have to look for while going through the setup. It's important to read through all these notes and make sure to do everything according to what the wizard tells you. So the first window as well as number 2 will give you some information about how to set up your radio. There are some notes about what to take care about so you don't get harmed by your helicopter, for example, by having it spool up by accident. This should not happen, so please read through these notes and follow them. In step 3, this is the first step where we start to really do some setup on the unit itself. So we are now asked to set up the servo type for our servos that we use. In our case, this is 200 Hertz. We do supply multiple options, as you can see, so make sure to use the option that's closest to the servo manufacturer's recommendations. In case you're not sure, better step one down, not to harm or damage the servo. The main rotor direction is clockwise, so this is the default already. We'll just keep that. And we step on to number 4. In step number 4, you now get the option to do some basic default setups like model size and flight style. So as I'm using a 500 helicopter for this example, I'm in the middle between these two, of course, but as I prefer not to have it too agile, I will stick with the default. And for the flight style, same thing, I will stick with the 3D soft option. We do also have a F3C, 3D acro, normal flying and scale option. This is mainly about agility, same for the model size, but there are some minor parameters that are slightly changed within these different settings. So again, I will stay with 3D soft. The mounting orientation is a real important part. If you get this wrong, your helicopter will most likely crash at the first flight. So make sure that you really have the mounting orientation correct. The 3 buttons down here are meant to rotate the unit in several ways. So in our case, we are again using the default setup, so socket row facing up and to the front, so in flight direction, and this is exactly the setup we want to have. On to step 5. In step 5, we need to define the input signal type. As mentioned before, we are using a serial input, not the cable loom, and to be more precise, we are using Jetty EX bus. So we just go into that drop-down menu and choose Jetty EX bus. Step 6 will ask us to do channel assignments. As we're using a serial input, this is very important because the unit can't know which channel operates what function. So this is what we have to tell the unit in this channel assignment table. It simply needs to equal your setup for the channels on the radio. So in our case, we do have aileron on channel 2, elevator on channel 3, tail on 4 is correct. No, sorry, tail we got on 5. Collective we got on 4. This is simply how you set up your radio, nothing special. So just check your radio's channel assignment and do it the same way in here. Throttle in our case is applied on channel 1. Head gyro is channel 7, that's correct. Tail gyro is on channel 6. Horizon channel on channel 8. That's it for the whole channel assignment. So we move on to page 7, which gives us the setup of the radio for the system. So we're getting into the diagnose page. In this page, you need to set up your radio exactly according to these little bars. I will now get the radio and the receiver hooked up and show you how exactly this works. So now I got everything powered up, radio, receiver, so the helicopter basically. And we now see these bars moving when I move the sticks on the radio. The goal here is to set up every single channel so that the center signal is pretty much exactly 0, that the directions, example aileron right, aileron left, go the right direction. Do the same for elevator nose down, elevator nose up. And the third thing to take care about, this is, by the way, all explained in step 8, is that the direction is correct and that the travel is correct. So again, example for aileron, aileron right to 100%, aileron left to 100%, center pretty close to 0. Same thing, of course, is what we do for collective pitch, up and down, and for the tail, right and left. And the next thing we can see in here is that we get information about what does the system see for the head gyro, tail gyro, throttle, and horizon channels. So especially for the initial flight, it's important to set head and tail gyro correct. We always recommend to go for about 45 to 50% gain. Tail gyro mostly preferred these days in heading hold mode, and the head gyro either in bank yellow and bank blue. We do not care about the bank setups right here. This will be explained in an additional video later on. So moving on to step 9 will give us a few more notes and hints. Please make sure to read through all this and follow the advices. Going to step 10, we get a new window at the bottom of the screen, the so-called deadband. This is simply for lowering the sensitivity around stick centers. So let's say you got some potentiometers in your radio sticks that are a bit worn out, but you don't want to change them yet, but they don't give you a real correct 0 for centers all the time. So you can use the deadband to just kind of get the system less sensitive to those variations around stick center. Moving on to step 11. This is where we now trim the servos to neutral. Very important advice at this point. This servo neutral trim page is not meant to level your swash or get any attack angles of your blade correct. So this page is only and really only for centering the servo horns, get them symmetric, get them 90-degree angle to the push rods, and this is exactly what we do in here. Everything else upwards to the swash blade and up to the blade grips is done mechanically on the push rods, not in this page. So the further steps give you advices about what you do. And finally, in step 15, we get to the next setup part. In step 15, we now have to set the swash plate type for our helicopter. There are different types available. In our case, it's a H320-degree linkage. And down here, you get the option to reverse the servos. So what we do right now is drive the swash plate up and down and check if all servos are moving the correct direction. If not, reverse the servos that are not moving the correct direction right in here. You can use these buttons to get all the servos moving the correct direction, so your swash plate will go up and down evenly and all servos respond as needed. Same thing is what you get for the tail direction down here. If your tail goes the wrong way, reverse it. And up here we get the option to reverse the aileron and elevator axis. So in case your swash is moving for the correct pitch direction, but aileron would be reversed, then simply use this reverse button to correct the aileron response. Same for elevator, of course. In step 16, you get the option to do some virtual swash phasing. This is mainly needed for scale helicopters, or at least any helicopter using a multi-bladed head, like 3, 4, 5 blades with a mechanical swash rotation. We can compensate for that in here. So moving on to step 17, which basically is the last step that really needs some setup to be done. Now we get to the servo travel window. The servo travel window allows us to now set all of our travels, which we usually do in the radio, but not with the flyballer system. It's done in here. So get your pitch gauge set up on your blade and now check for your collective pitch range, for your elevator and aileron range. Especially on elevator and aileron, we want to see a 9 to 10 degree deflection, which is best for the system. For collective pitch, well, if you have a standard trainer or 3D setup, you usually would go from something between plus minus 11 to plus minus 13 degree. Whatever, all this is set up in here. So if your aileron travel is too high, let's say you put your pitch gauge on, you go full aileron right and you get a 13 degree, then go in here and just lower the travel. You will see it directly on your pitch gauge that the travel is going down. So just get it to the point where the result is something in between 9 and 10 degree. All further steps, 18 to 21, give you some more advices, what to look for, what to check prior to your first liftoff. And, well, congratulations, the basic setup is completed successfully. That's it. No magic,